Hi everyone, welcome to the last lesson of Algebra 1 and lesson 120. Use geometric formulas to find the probability of an event. So we've been working with different kinds of probability this year, theoretical and experimental. This one, geometric probability, is very similar to theoretical probability. And the main formula that you're going to be using is the area of the smaller shape divided by the area of the big shape. So we'll be dealing with rectangles and circles and a variation of two different geometric shapes. Let's take a look at an example 1a. Find geometric probability with rectangles. So you can see an example on the left-hand side here. They're comparing the tomato section of a garden with the whole garden and finding the probability that a bird lands in the tomato section. We're going to do one with a sheet of paper that's on a table where what is the probability that the fly will land on the paper. So just to get a quick picture, here's your table, and then there's a piece of paper inside here. So we want to know the area of the paper divided by the area of the table. So if I substitute the numbers in, area of the paper, they said it's 12 by 9, and the area of the table is 15 by 18. Now, I didn't do all the multiplication here with that. I just kept the factors in there because it's going to be easier to simplify here. So if I want to simplify, I'm going to divide a 3 here, and that gives me 4. Divide 3 out of 15, and that gives me 5. Divide 9, you get 1. 18 divided by 9 gives me 2. Now I can simplify even more. I can divide a 2 here, divide a 2 here, and that leaves me with an area of a probability of 2 over 5. And that would be the probability of that fly landing on the piece of paper that's on the table. Example 1b. Same thing, but this time you have a swimming pool and there's a raft in the swimming pool. And we want to know what is the probability that the ball hits the raft. So we have the area of the raft divided by the area of the pool. So the area of the raft is 2 times 3. The area of the pool is 15 times 30. And then we can simplify, divide a 2 here, divide a 2 there. Take a 3 out here, take a 3 out here. So now I have 1 times 1, 15 times 5 is 75. So you have 1 out of 75 chances of the ball hitting the raft. Example 2a, find geometric probability with circles. So you're going to be dealing with area of a circle, so pi r squared. So here it says a parachutist jumps from a plane. The target area for his landing is a circle with a diameter of 40 meters. So let's say here's the landing spots. So directly across is 40. And there's one large pond that covers an area with a diameter of 10 meters. So let's say this is the pond. This one has diameter of 10. What is the probability that he lands in the water? So we have the area of the pond divided by the area of the landing circle. So now I have pi r. The radius of the pond is half of 10, so that would be 5, and I need to square it. Divided by the area of the landing circle, pi times the radius squared. Half of 40 is 20. So if I simplify this, this is 25 pi. This is 400 pi. And then to simplify this, we can determine that the pi's can cancel out. I can divide a 5 here. That gives me 5. Divide 5 out here, and that gives me 80. And then I could divide a 5 out here and gives me 1. Divide a 5 out here, and that would give me 16. So you would have 1 out of 16 chances of landing in the water. The next example, 2b, finding geometric probability with circles. A child's crown is made by cutting the 6-inch center out of a 10-inch piece of paper plate. The plate is then decorated by sprinkling it with glitter. What is the probability that a piece of glitter misses the crown? Okay, so we have the plate, area of the plate, and then we have area of the crown itself. So we're going to have the area of the inner part divided by the area of the outer part. So we need pi times radius squared of the blue part. So the radius is half of 6, which would be 3, divided by pi times the radius of the diameter of 10. So half of 10 would be 5 squared. So that would give us 9 pi divided by 25 pi. Pi's cancel out. That leaves you with a probability of 9 out of 25. Example 3a, finding the probability of the complement. What they mean by the complement is everything around the smaller shape. So it doesn't land in the small shape, it lands on everything on the outside of the small shape. So a round piece of cardboard with radius 4 inches is used to make a mask. A 2-inch square hole is cut for a mouthpiece. If a piece of popcorn is tossed at the mask, what is the probability that it will miss a mouth hole? So now to set this one up, if you refer back to the left-hand side here, you can see an example done for you. This one has a circle and then they have a square in there. So they have the area of the park divided by the area of the town. So just like we did before, but then you have to subtract the area of both, so the whole thing. So it'd really be 1, subtract your answer from 1, okay, because the probability of not landing in the park versus landing in the park is 1 minus the probability of landing in the park. So that's where your 1 comes from. So here, let's find out what is the probability of it landing in the mouthpiece. So first off, we need the area of the square. So we have 2 times 2 divided by the area of the circle. And the area of the circle has a radius of 4. So it'd be 4 squared, which would be 16. So 16 pi. If I were to simplify this, this would be 1/4 pi. And so now I'm just going to take my answer, and I need to take that away from 1. So 1 minus 1 divided by 4 pi. So if I come to my calculator here, and I do 1 minus parentheses 1 divided by 4, I'm just going to put the pi symbol in, divide that, that gives us 0.2146 as our answer here. That one I did something a little bit wrong. I put it in the calculator incorrectly because what happened was I put the 1 divided by 4 and they did 1 divided by 4 and then they multiplied it by pi. So I got to do that a little bit differently. So I'm going to take 4 times pi, find that, so that's 12.56. I'm going to take my 1 divided by that answer, so second negative sign, so that gives me 0.07. Now I got to take 1 and I got to subtract that from my answer. And that's how we get 0.9204. So the probability would be about 0.92. So just make sure when you're putting this in your calculator, you put this in correctly. The first time I put it in there, I did not put that in correctly. So I would just do 4 times pi, solve that, take 1 divided by your answer, solve it, then take 1 minus that answer to get your 0.92. Example 3b. A rectangular yard is 10 feet by 15 feet. Tulips are planted in a triangular area that has a 5-foot base and a height of 6 feet. A bird lands in the yard. What is the probability that it does not land in the tulip garden? We're going to do the same thing. The whole area minus the probability of it landing in the triangle, in the tulip garden. Okay, so I need to find the area of the triangle first. So area of a triangle is base times height divided by 2. So the base is 5, the height is 6 divided by 2. That will give me 15. This is all over area of the rectangle, which is 15 times 10. And I know that the 15s can cancel each other off. So that gives me 1/10. So 1/10 is the probability that it lands in the tulip garden. So now I just take my 1 and I subtract it from 1/10. That will give me a probability of 9 out of 10 chances. If you put it as a decimal, this would still be as 0.9. Either way, a fraction or a decimal will work. And the last question here, an application. A rug in the kindergarten class has various shapes on it. One student steps onto the rug. What is the probability that he is not standing on the square? Okay, so this is a complementary one. So complement one. So what we need to do is doing the same thing as what we just did on the previous ones. So I need to find out what is the probability of getting on the square. The square is a 2 by 2. So that is 2 times 2 give us 4. The probability of the whole rectangle is 6 times 8, which will give us 48. If I were to reduce this, this would be 1 out of 12. If I take the whole thing and I gotta subtract everything that's not the square, which is 1/12, that would give us an answer of 11 out of 12 as our probability. Hopefully that helped you with geometric probability. Your final assignments for the year would be lesson 120, numbers 1, 5, 8, 9, and 10.